We are now going to begin solving compound inequalities. So what I have here is the equation -5 is less than x minus 4, which is less than 2. This is considered an AND situation, and it will always be an AND situation. That means whatever solution we come up with, it has to work everywhere. When we're given these type of problems, we're going to break them apart. Here will be equation number 1. We're going to solve -5 less than x minus 4. We will then go back and solve this equation. X minus 4 is less than 2. So we were working with one-step equations. I would add 4 to both sides. -1 is less than x. Now I'll go over here and solve. I would add 4 to both sides. X is less than 6. So because it started this way, our final solution would be -1 is less than x, which is less than 6. When I graph this, I'm going to have an open circle at -1. I would have an open circle at 6. We know we need all numbers where x is greater than -1 while x is less than 6. So my shading would be between the two open circles. Here are where I'll find all the solutions that work here and here. Something very, very, very important to note. Highlight it, star it, do whatever you need to do. When you give your answers, they need to be in numerical order. Numerical order means you'll give me least to greatest. And by least, we know we mean the smallest to the largest. Always numerical order. -1 is smaller than 6, so I put that in that order. You also always use the less than or equal to signs. Because you put them in numerical order, you will always use less than or equal to. Okay. Here we have another math problem where 7 is less than x plus 2, which is less than or equal to 11. We will divide this into two math problems. And so I would have these two math problems to solve. When I'm given a math problem that looks like this, we know it will always be AND. I need solutions that will work here and they will work there. Solving this one-step equation, I get 5 less than x. Okay, then I will come to the other side and I would get x is less than or equal to 9. I will write my final answer, putting them in numerical order. 5 is smaller than 9, so it goes on the left, using less than or and equal to signs only. If I was asked to graph, I would have open circle at 5, and I would have a closed circle at 9. Now, I need all x's greater than 5, less than or equal to 9, so I would only shade in between those 2 points. Here is a two-step equation. I would like you to try this one by yourself. Pause the video. You're going to break it into two math problems. Sketch a graph like I have done right here. We'll compare answers in a moment. Please pause the video. Thank you for pausing the video. I broke it into two separate equations. Hopefully I did my math correct, and I have x is greater than 4. When I went over here, I have x is less than 10. I wrote it together. Now I put it in numerical order, so I have open circle at 4, open circle at 10. I need all x's in between, so I shaded in between. Okay, we need to turn to the next page. Now, because we were given an or situation, we will never have it written compound together. We will just simply solve our one or two step equation. So I would subtract 4 from both sides. Negative 3x is less than 15. Oh, remember the rules. When I divide by a negative or multiply, I have to flip the inequality sign. Remember to think of all of that. On this side, I would add 3. 7x is greater than 21. Divide by 7. X is greater than 3. So my answer would be x is greater than negative 5, or x is greater than 3. Ooh, this is interesting to me. Okay, I am going to sketch a number line. I did not write this as one sentence like we did in the last problem because of the word or. I have negative 5, open circle, shaded to the right. I then would have positive 3, open circle, shaded to the right because they're both greater than. Now I better test this because I'm noticing a few things. In our other or situations, I had arrows to the left, arrow to the right. So I'm going to test 0. Just going to figure out what is going on here. I'm going to say let x equal 0 to test. If I put 0 in here, wait a minute, x is greater than negative 5, so that's true. I'm going to test it over here. 0 is greater than 3. Oh, that's false. But that's okay because we have an or situation. This number needs to work in one or the other math problems. Okay, I'm going to grab another number out here. I'm going to grab the number positive 5. Just feel like it. You could have picked 100, whatever you want. If I test this with x being 5, 5 would be greater than negative 5. That's true. I put 5 here. 5 is greater than 3. That is true. So this number 5 works in both math problems. That's just a bonus. So my final answer for this would be any number greater than negative 5 will work in one or the other equations. So there's my answer. Okay, we just are kicking it up a notch. What kind of math problem is this? Would this be considered an and or an or situation? Do we need solutions that work in both or just one of the math problems? This is an and situation. I'm going to divide the math problem into two parts. And we're going to solve being very careful. I'm going to pause the video. You do not need to graph yet. I would like you to solve this equation and then this equation. We'll compare answers in a moment. Please pause the video. Think about the rules for solving multi-step equations. Thank you for pausing. Let's just take a moment and review. When I solved what I wrote in green, I ended up with x's greater than or equal to 3. When I solved in purple, I ended up with x's less than or equal to 5. If you have different answers, pause the video, compare your work to mine. Because it was given to me in a compound statement, I'm going to write my final answer in a compound statement. Least to greatest, always using less than signs. So x is going to be greater than 3, and x needs to be less than 5. On a number line, I would have a closed circle at 3, closed circle at 5. I need all numbers in between 3 and 5, so I will shade there. I'm going to ask you to pause the video again. These are solving two-step equations. You don't need to watch me do that. We'll compare our solutions in just a moment. Please pause the video. Thank you for pausing. Let's just take a moment and compare our answers. When I solve the first equation, I have x is greater than or equal to 4. When I solve the second equation, I ended up x is less than or equal to 3. We do not need to write our answers compoundly because they use the word and. On a number line, I would have closed circle at 4, x is greater. On this one, I would need closed circle at 3, x is, oh dear. Okay, this is an and situation. Where on this number line do you see numbers that would work for this problem and that problem? I don't see any. This problem requires numbers smaller than 3. This one requires numbers larger than 4. Therefore, when this happens, there are no solutions. Because of an and situation, there are no solutions. If this was an or, where I just needed a number to work here or here, this would be a marvelous graph. This graph does not work with the word and.